Welcome to the History of Radiography and the Production of Dental X-rays. This presentation is directed toward the dental assisting student. So in 1895, a German physicist named Wilhelm Conrad Röntgen was working with, experimenting with something called a Crookes tube in his lab. And he was experimenting actually with the properties of cathode rays and shadow casting. During his experiment, he accidentally passed his hand between the Crookes tube and a fluorescent screen, and there on the screen was an image of his hand. It wasn't just his hand as he was seeing it, but the actual bones in his hand. Well, he was so excited that he ran and got his wife Bertha, and then took her hand between the Crookes tube and the fluorescent screen and also duplicated what had happened. There was her hand with a ring, and it was the bones of her hand. Well, she was horrified. She felt like she had seen death and never went into the lab again. He, Röntgen, named these rays that now projected the bones of his hand onto a screen, X for the unknown. And for a time, they were also known as Röntgen rays. Another German physicist, Dr. Otto Walkhoff, is credited with using the Röntgen rays for dental purposes. He actually took a photographic plate and wrapped it and placed it in someone's mouth to get an image of teeth. Well, this took 25 minutes. So for 25 minutes, a person was exposed to radiation. Another dentist in the U.S. is credited in some historical accounts for using X-rays in dentistry. Dr. Edmund Kells, he's also credited for utilizing dental assistants. Aren't you glad we don't have to dress like this for assisting? Now, Dr. William D. Coolidge decided to improve upon the Crookes tube, making it bigger and better, and so he named it the Coolidge tube. Very interesting apparatus here. Well, as equipment goes and the development of equipment, it became smaller over time, and here's what we have today, which is known as a cathode ray tube. And that is actually in the tube housing of our X-ray unit. Well, in the early 1900s, people started using X-rays for various purposes. In medicine, it was thought that having radiation treatment could relieve headaches, but as you see here in this advertisement, it took 15 minutes of exposure that they thought would relieve headaches. Very long time, as we know now, for exposure, and it cost 25 cents to have this exposure to relieve headaches. It was also used as an art form, so kind of drawing on what Röntgen had experienced. You could go into an X-ray studio and have your hand X-rayed, and it would be put on photographic paper, or it was actually a plate, not an eating plate, but a square, and could be used as an art form. And then it was used in service. And so this is a young boy standing on top of a machine that is going to radiate or irradiate his feet to get his shoe size. So this was used for shoe sizing. I don't know how long it took to stand on this equipment to be X-rayed to get your shoe size, but we see here, and what we know about X-rays now, is that people really were subjected to X-rays for a long time for various purposes. So it would be interesting to really do some research and find out like what was happening to these people. We know X-rays causes tissue change, so that would be very interesting. Now let's look at the production of dental X-rays. As we do this, or in the beginning here, we're going to look at some very, very basic physics. Let's look at the atom, which is a small particle of an element, and the smallest particle of an element. So there are 118 basic elements, and they are listed in what we know as the periodic table. The atom, or atoms, consist of electrons and a nucleus. In the nucleus, there are protons and neutrons. The number of protons in a nucleus determines the type of element. So we have the atomic numbers. The neutrons determine the isotope of a chemical element, or a variant form of the element, or you could just say a different form of that element. In the atom, there are also electrons revolving around the nucleus, and they are considered to have a negative charge, where protons have a positive charge and neutrons are neutral. These negative electrons travel around the nucleus in a path called a shell. And we will see that the electrons are involved in creating dental X-rays inside this vacuum tube, the cathode ray tube, which is inside the tube housing. Some more very basic physics terminology. One of them is wavelength. So when X-rays are actually produced, they travel in waves, but they travel in a straight line in these waves. And the distance between the waves is called wavelength. You could think of these waves and wavelength. If you go to some gyms now or work out where they have the battle ropes and you're moving the rope up and down, that's creating a wave, and that's what happens with electromagnetic waves, which X-rays are part of that. We also look at frequency, so the number of wavelengths that pass a point within a given time. Now, this comes into play and will make a little more sense here in this statement. The shorter the wavelength of electromagnetic wave, the higher the frequency. And the higher the frequency, there's more energy in that electromagnetic wave, and the more energy, the more penetrating that is, and that type of electromagnetic wave or radiation. So here is yet some more very, very basic physics. This is called an electromagnetic spectrum, and you can see on the bottom of this spectrum we have non-ionizing radiation and ionizing radiation. On the very top, we can see the various equipment or sources, I would say, because we come to the sun, which is not equipment, but sources of radiation that we have on our planet. Here you see the wavelength and the different points or the frequencies of the wavelengths. So the word ionizing means that ions are produced, and ions can create cellular changes. That's what ionization does, is it can create cellular changes to structures of tissue. And of course, as human beings, we're concerned with that. And science is concerned about how these electromagnetic waves, the non-ionizing radiation and ionizing radiation, affects humans. And we should also be concerned about animals. So an ion is an atom that's missing an electron with a positive charge or extra electrons, and that carries an electrical charge. So if we look at electrical towers, computers, cell phones, microwaves, and also infrared, we see that it is non-ionizing radiation, which means that in most scientific study, it does not create tissue change. Now, we've also heard about how you shouldn't be around or have cell phones close to our body, which we all do, but there are studies that perhaps show some causal links to tissue change. Some people don't like to be around microwaves or computers, which most of us are. And then as we get into the sun, there's visible light rays, but there's also ultraviolet. And we all know we want to protect ourselves from ultraviolet rays. We wear sunglasses, we use sunscreen, we use clothing or other means of blocking out ultraviolet rays from the sun. So that does cause tissue change. If you're out in the sun too long, you may get a sunburn. That's changing your tissue. Then we have X-rays that are used in, of course, medical and dental settings, and these do cause tissue changes. So that's why we need to be very careful about when we use X-rays, because it does cause tissue changes, cellular to the cellular structures of the tissue. And then there are gamma rays, which are the shortest wavelength, which is actually radioactive materials. And we know that's very harmful to human tissues. So knowing the electromagnetic spectrum of non-ionizing radiation and ionizing radiation, we do have to have careful consideration when exposing humans to ionizing radiation. Let's look at some properties of dental X-rays. They're invisible, so that when we are exposing an image on a film or a sensor, we don't see anything coming out of the X-ray tube housing or the PID. They're invisible. X-rays travel in straight lines. So as long as you, as the dental radiographer, the operator, have positioned yourself out of the way of X-rays, you are going to be safe working around X-rays. Now your patient is in the line of the X-ray. However, again, we're going to only take X-rays when it's evidence-based, when a patient really needs X-rays for diagnostic purposes. Also remember that they travel at the speed of light. So as soon as X-rays are produced, when you hit the button to expose the film or the image receptor, that's when X-rays are produced. And traveling at the speed of light, that is 186,000 miles per second. That's before you can go snap your finger, before you go up, they're gone. Okay, so there's really no need to be frightened of using X-rays if you're following proper protocol, and we'll look at that in another presentation. They have no mass or weight. Your patient doesn't feel it. They have no charge. They interact with matter causing ionization. That's why we need to be very careful and use them selectively. They can penetrate tissue and structures depending on the wavelength of the X-ray and the thickness and density of the object, meaning the teeth. They can affect photographic film or digital sensors, and they do affect biological tissue, and it's cumulative. So once you have tissue change from X-rays, that stays. That doesn't usually change itself. It depends on the amount of exposure that you've had. So we, again, are very careful about exposure to our patients. And therefore, careful consideration must be made when exposing humans to ionizing radiation because it can affect biological tissue and it is cumulative. So let's look at the physical production of dental X-rays. It happens in the vacuum tube or the X-ray tube that is in the tube housing of our dental X-ray unit. With the dental X-ray unit, there is a panel, and there needs to be an electrical source for that panel. So usually it's connected within the wall. We have an activation or exposure button, which is outside of the room where the X-rays are going to be produced, and that is the only time when X-rays are actually produced in the vacuum tube. So think of our dental X-ray unit like you do your TV. You leave a TV, you leave your stereo, you leave your computer plugged in most of the time into the outlet in the wall. So there is a source of electricity. However, nothing happens until we actually, for our TVs, hit a remote or have voice command. So nothing actually happens until it's activated. And the same thing with dental X-rays and our dental unit. How X-rays are produced. So in the tube housing, we have the vacuum tube. And I'm just going to go through some terminology. In the next slide, we'll actually look at a diagram. So in the tube housing, we have the vacuum tube. We also need to have and engage the activation exposure button. Then in the vacuum tube, there are some different parts. One is called a cathode that has a filament. Another part of the tube is called an anode. It has a tungsten target and a focal spot. And then we have X-rays that leave the vacuum tube through the tube housing, through a port, an aluminum filter, a lead collimator, and finally travel through the PID that is directed toward the teeth. Here is a diagram that you can find on the internet, you can find in your radiography textbooks, and it is a diagram of the X-ray tube housing, and inside is the vacuum tube. So, in the production of X-rays within the tube housing, first of all, the vacuum tube is surrounded by oil that helps to balance the heat that is going to be generated from this electrical source. And the tube is also, the tube head or the tube housing is lead lined, so no X-rays, if your equipment is in proper working condition, can escape the X-ray unit or the tube housing. So what happens with it starts with the electrical source. There is a filament, a tungsten filament, in the part called the cathode. And that will create, this is when you engage the exposure button or activation button, will create a cloud of negative electrons, and the filaments are heated, and that sends or directs the negative electrons across to the anode. They're attracted to the anode. However, they are stopped by a piece of metal called tungsten, and they're stopped by the tungsten target. Now, at this stopping, it creates some energy, which is creating the X-rays or the radiation. And part of the radiation is called general radiation or Bremsstrahlung radiation, and this is the majority of the type of X-rays, and it just has to do with the type of energy that's formed by these electrons being stopped by the tungsten target. Another part of the X-rays or the X-ray photons, the particles, are called, it is called characteristic radiation. And this is a small part of the radiation. So two types of radiation are actually produced: general radiation and characteristic radiation. Once they are, once the radiation is produced at the tungsten target and the focal point, they then are directed, because of the position of the tungsten target, through a window of the vacuum tube. And from the vacuum tube, it is then released from the vacuum tube into through a aluminum filter, which helps to narrow the X-rays, the radiation, the X-ray beams. And then, because remember, X-rays travel in a straight line, so you can think of them as beams. And then to further restrict the width of those X-ray beams, there is a lead collimator. And lead is a metal that will help to stop the penetration of X-rays and therefore can narrow the beam. And then from the still escaping, because they're traveling, remember, at 186,000 miles per second, they are then released through the PID, and we have directed the PID. Remember, the X-rays are made of photons or bundles or particles of energy, and they're traveling in a straight line. So this is the way X-rays are produced in the cathode ray tube or the vacuum tube in the tube housing. Let me talk a little bit about the focal spot, which is a place on the tungsten target. And in the manufacturing of the machine, the focal spots can be different sizes. Through experiments, through the development and the modernization of X-ray equipment, it has been found that the smaller the focal spot, so the smaller the beams of X-rays, of radiation, you get actually a sharper image. So now, in the anode of the X-ray tube, the focal spots are very small. They're actually, an area on the tungsten target. And so they're small, which gives you a more sharper, defined quality image. Now, when radiation is released from the tube housing through the PID, you have primary radiation, or sometimes known as the central ray, in the primary radiation, which is what is going to affect your image receptor. And therefore we have our image either immediately through digital technology or the latent image through film. The other parts of the X-ray then deflect off of the teeth and off of the face, and that is termed secondary radiation. Remember, they travel in a straight line, so it's not like it hits the tissue and then just kind of explodes out into the room. They're still traveling at a straight line, but just by the nature of the X-rays penetrating tissue, there is some deflection, which is secondary radiation. Then there is also another deflection off the tissues that is referred to as scattered radiation, which is very, very minimal. But this is the formation of different types of traveling or paths of radiation. And the primary radiation sometimes is called the useful beam. Now, once again, we do not need to be afraid of radiation. We just have to work smartly with it. So if you have your PID, as in this picture, directed toward the patient's teeth, which is the purpose of us taking radiographs, an image of the teeth and the internal structures of teeth, and then you have some secondary radiation, as well as some scattered radiation, which is minimal. It's all traveling in a straight line. So as long as you, the operator, are not in that path of the PID, the direction of the PID, you're going to be protected. So we'll look at standards of protection in another slide presentation. But you do have to work smartly with dental radiation. So let's review. Röntgen discovered X-rays accidentally, and eventually the X-rays contributed to medical and dental treatment. They are only produced when the activation exposure button is engaged, and they are produced in the X-ray tube housing in the cathode ray tube. X-rays travel in a straight line at the speed of light. Therefore, we can protect ourselves and our patients. X-rays do affect biological tissue in the process known as ionization, and they should only be used. Therefore, they should only be used when prescribed. That concludes the history and production of X-rays, and thank you very much for your attention.